motors and the batteries don't struggle to keep it in the air. This is the motors. The thrust that allows the quadcopter to get airborne is provided by brushless DC motors, and each of them is separately controlled by an electric speed controller or ASC. So you need also a propellers. As you can see, the propellers are already connected to the motors. It Using a propeller, it depends on the type of a quad you build. You can use 9 to 10 or 11 inch. So here's the ASC, electronic speed controller. It's like a nerve that delivers the movement information. It regulates how much power the motors get, which determines the speed and direction changes of the quad. So there it is, the frame. The frame is the very base of your quadcopter. There you can install the ASC, the battery, the propeller, and the motors. The motors are positioned in every corner. You have two motors that rotates in a clockwise direction, while the remaining two on the opposite diagonal rotates counterclockwise. If this wasn't the case, the quad would only spin around like a traditional helicopter when the tail rotor dies. So here's the Arduino, the flight controller. It comes with 14 digital input or output pins. 6 of them can be used as outputs for PWM. 6 analog inputs, a 16 MHz quartz crystal, a USB connector, a power jack, an IC/SP header, a reset button. So here are schematic. This is the main blueprint of our operation. How to connect the ASC. Signal pin ASC1 D3, signal pin ASC3 D9, signal pin ASC2 D10, signal pin ASC4 D11. How to connect the Bluetooth module TX to RX, RX to TX. How to connect the MPU 650, SDA to A4, SCL to A5. How to connect the LED indicator, LED anode leg to D8. So how to connect the receiver, throttle to 2, ailerons to D4, ailerons to D5, rudder to D6, auxiliary 1 to D7. We need the MPU 650, the Bluetooth module, the receiver, and the ASC to be grounded. And to do that, we need to connect the all ground pins to the Arduino GND pin.
Here's the order which you needed to solder all the pieces together. First thing you need to do is to take the female headers and solder them to the prototype board. This will house your Arduino board. Solder them right in the center so that there's room for the rest of the headers for the MPU, Bluetooth module, receiver, and the ASCs, and leave some space for the additional sensors you may decide to add in the future. The next step is soldering the receiver and ASC's male headers right from the Arduino female headers. How many male AC headers you will have depends on how many motors your drone will have. In our case, we are building a quadcopter, meaning there will be 4 rotors and an AC for each. That further means there will be 4 rows with each having 3 male headers. When the AC are finished being soldered, you can move on the receiver header soldering part. In most cases, a quad has 4 channels. These are throttle, pitch, yaw, and roll. The remaining free channel is used for flight made changes. That means you will need to solder male headers in 5 rows. So that's all for the soldering part.